All right. Thank you so much, Dixon, for this introduction. Hi, everyone. My name is Safwan. I am a junior ML engineer here at ZenML, and today we will try to present and demo the BentoML integration. So maybe let me share my screen. Right. So again, welcome everyone. Before starting actually talking about the integration itself and what can it do, maybe let's just give it a quick recap about what is ZenML and what are the core concepts. So ZenML is an MLOps open source framework that tries to sort of leverage and unify all the tools, integrate all the tools in the MLOps landscape in a way that you can write one single pipeline and move from a local environment into a production environment without any extra configuration. And as you heard me, maybe the first component and the most important one would be that ZenML code is wrote in steps and pipelines. And this is very important later on for explaining the demo and the integration. So everything in ZenML is actually a group of steps that are grouped together in order to create this workflow we call the pipeline that can execute whatever the job or task we want to do. The other thing, which is the second most important concept, is stack and stack components. And basically stack is a group of stack components, and stack components is the underlying configuration that ZenML use to take care of doing specific tasks or connecting or interacting with specific tools. So for example, we have orchestrator, and there is multi flavors. We call them flavors of orchestrators, local one and remote ones, such as Kubeflow or Tecton and other flavors. And for artifact store, it's the configuration where the file is going to be stored. There is a flavor for S3 buckets, for Azure Blob Storage, and GCP and other stuff. So now that we have this sort of general idea about what are the core components about ZenML, let's maybe talk about the main components we have today, because we are talking about integration of BentoML into our model deployer stack components. And the model deployer stack components have mainly three roles, or does three things. First, it handles all the related configurations that would make ZenML interact with that tool or that framework for deploying and serving the models. That's the first. The second thing is implement some built-in steps that would make it easier to deploy the model either locally or to a remote cluster or something like that, which will then leverage continuous pipeline training and continuous deployment. And the final thing acts as a registry of services. And by service, we mean the actual deployed models are stored as a service that ZenML then can sort of check and see what exact models are deployed for this specific pipelines or this specific projects. Now that we understand a bit what is that, we're gonna talk about this specific stack component, which is called model deployer. Let's talk about BentoML, which is an open source model serving framework. Well, I think I took this from their website, and it's basically this is one of the main functionalities. Well, first it tries to simplify the model serving and deployment, and make it much easier. And to do that, one of the way is to support all the popular ML framework, and also support to integrate easily the custom pre-process and post-process code with your models to deploy them. The other thing is standardize the deployment process. And this is done by something called a Bento artifact, which is basically a package that handles all your models, your code, and also some metadata that will be relevant when you want to either build a Docker image or to deploy the same model in some remote place. And the other thing, which also very good about ZenML, about BentoML, sorry, is to automatically generate Docker images, which you can use later on to deploy using one of their tools such as Yatai or like BentoCTL. And finally, you can deploy locally in a Kubernetes settings or in a cloud environment. Now that like we have sort of a general idea about each of these stuff, which are really important to go into the demo, let's try to demo this. I'm gonna switch my screen. Okay, so for today's demo, we're gonna actually like, this will be a very sort of advanced example. We're gonna try to see how we can use like BentoML integration in order to deploy a Zen file or like Zen project we have, which is related to a signed language, American Sign Language object detection used in YOLO 5. So the first thing, maybe let's try to explain exactly how the pipeline looks like. So we have actually three ZenML pipelines. The first one will be like for training, which will load the data from the RoboFlow platform, try to augment like the image of the training set, do the same for the validation, the validating data set, and finally do a trainer that will train on a remote environment using another stack component called step operator, which will train in Vertex AI. And like, this is not actually our main pipeline here, but after that, what we're gonna try to do is try to get that model that was trained previously in Vertex AI using a GPU and stuff like that, get it locally, try to build a Bento, which is like, will be the main sort of artifact that ZenML use in the integration. And after that, deploy that Bento locally. And finally, we're gonna try to use the same Bento that was like built locally to deploy it into a SageMaker endpoint. So now that, let us maybe sort of see exactly how each of the steps looks like, just briefly. First, we have, let's try to see data loader. Okay, this is it. So this is just trying to get like the data from RoboFlow and then save it into our artifact store. Once that is done, we have the training that like train augment that will try to augment the images using augmentation like framework. And once these two are done, we will try to train our model using a step operator, which will package everything and like train it in a Vertex AI job. After that, and this is where we're gonna start using actually BentoML. In order to start using BentoML, the first thing you would need to do actually is to register a stack and then register the BentoML stack component integration. And to do that, let's maybe try to see. Actually, we can use our CLI. We have a bunch of, like, you can see here, a bunch of stacks that I have already registered. And for right now, I'm using the Vertex MLflow BentoML stack, which like has a bunch of stack components such as like experiment tracker, container registry, and stuff like that. And like now let us maybe register. If we want to register a BentoML component, what we would need to do is do ZenML model deployer, and then register. Sorry, register model deployer. Register BentoML, because like I have already have one here. I'm gonna try register a new one. So I'm giving it a new name, flavor, and then give it BentoML. So that's it. That's basically what we need to do, just to register the BentoML. And after that, we need maybe to like update one of these stacks to use. For example, let's try to update the local Bento one. To do so, we need to do ZenML stack update local Bento, and then deployer and give it BentoML do, for example. So now, like, it's trying to update. If we try to do ZenML stack list to see like our it's updated and we have like the new component there. As we can see, our like the local bento stack have now the BentoML2 model deployer. And right now, let us maybe go to the second pipeline, which is like the most important. We will see like BentoML integration in action. And in this pipeline, which called like YOLO 5 deployment pipeline, we will try to get the model that was trained previously in the training pipeline, then do like deployment trigger, which just check if we want really to deploy this model or not. Try to use the built-in step, which called Bento Builder, which like just to get a bunch of parameters and tries to do all the work of like packaging the bento and like building it in the ZenML artifact store so we can use it later on. And finally, a deployer, which is also like a built-in step that deploys the model locally. And maybe let us more see the bento builder and deployer steps. So the bento builder, this is the bento builder steps, and like basically what you have to do is just import the BentoML builder parameters and the step, and then you can give it like the parameters you want to be like set for your bento. It's more like some metadata parameters, and like for that we have the model name, the model type. This is very important because like later on under the hood, ZenML tries to use BentoML API to save the model using specific framework. So if the model was trained using PyTorch, we would need to specify here PyTorch. If it's like sklearn, scikit-learn, or like TensorFlow, we need to specify TensorFlow. After that, we need to provide the service. And actually, like the service is the core logic of BentoML. It defines how exactly that model will be served. And a bunch of labels that we want. After that, we want, for example, to exclude the folders that contains the data in our project, because then our Docker image that we will build in and the BentoML will be like huge and may affect our performance, which we don't want. We can also select like some requirements because we are using YOLO v5 here. We would need to install all the requirements that YOLO v5 uses. And like we can specify that using Python requirement.txt and then give it the path of the requirement txt. And finally, also because like this is sort of like advanced example, we would need Docker image to have some system package, and I'm just specifying that in the Docker. So this is like basically how Bento builder will look like. Just give it this bunch of parameter, and then ZenML built-in step will try to handle all the rest. And like once that is built, we can move on to the deployer, and deployer actually sounds much easier because like all you can get is like the parameters and the deployment step, just like the builder, and give it the exact parameters that BentoML requires in order to serve an actual bento, which is like in this case the model name that we want to say. This is more specific to a ZenML, the port, and if we want to be this like to be production or not. So maybe what we can try here is try to run the actual deployment pipeline to see this in action. So what we're gonna do, like deploy. We took a look to the run script. We can find that like we are just calling the same pipeline for like try to get it from here and then give it whatever like steps we want and then run it. And that's exactly what we are doing with the deployment one. So now actually like this starts. This will take some time. Like meanwhile, we can actually see some other stuff here. Let me switch my screen. Sorry for that. So while that is actually like trying to save everything locally and building the bento and deploying it locally, Actually, ZenML provides a dashboard that you can see all this stuff, like the runs that you have done and the pipeline definition, stacks and stack components from one place. And maybe let's go to model deployer. We can see that like we have Seldon key serve, BentoML1, and like BentoML2. And what we want to focus on is actually our pipeline. Let's maybe try to see exactly, actually, like, because I have run this several times, if we go to the deployment one and we go to the run, we can see that like this have been executed multiple times, and we can even sort of see exactly what was like the status of every steps and the whole pipeline. So this is, for example, the model loader. What it tries to get is the model from the previous trained pipeline, and then it saves the model to the artifact store. After that, we have a bento builder, which built the bento and then save it into, because we are using GCP artifact store here, it saves that into GCP, and we can actually see it from GCP. ZenML exported .bento, which was like exported from that previous pipeline. Then the deployer, it will try to deploy everything. And like maybe now it would be a good idea to see if like that's finished or not yet. Okay, so actually we got the model from like the previously trained pipeline, and we start building the bento. As we can see, this is like, I don't know if you have used BentoML before, you could see like this is the logs of BentoML, which shows exactly that we have successfully built a new bento here. Now we just need to wait once that is done, and like we will go to the deployment step, which will deploy this bento locally, and we can actually run some prediction on it. This is taking some time. After that, after like we have this deployment one is done, we're gonna try actually to run a new simple pipeline, which is called inference pipeline. And this one is actually like trying to get the data we want to run the inference on it. And like after that, do prediction service loader. And this what does exactly, it's just try to get the exact model we want to run the prediction on it. Because like if you have a lot of models, well, basically we would need to select the right one to run this prediction on it. And this is done by like a custom step that we call prediction service loader. And if we go to the step, you need to specify the exact pipeline name used to train that model, the step, and the model name. And finally, the predictor, which will just try to predict on it. Actually, this is a big model, so it's taken some time. Meanwhile, what we can do actually is see the exact. So if we run BentoML list command line, we can actually see like all the built bento, and the latest one was just like 3 minutes ago, which is this one. It was built and stored locally. And like we can actually then use this bento, which we will show like in a few minutes, how we can use the same bento that we tried locally in order to deploy it to an actual SageMaker endpoint. Okay, maybe we're gonna try to do that because this is taking some time. If we want to actually like to deploy our built bento within the pipeline into a SageMaker or any cloud environment, what we're gonna need to do is first to install BentoCTL, which can be done by like doing pip install BentoCTL. Well, I think we have already that, so that shouldn't like try to install it again. And after that, we can select the exact operator we want. And in this case, BentoML has actually like a list of operators from an actual like Google instance, VM instance, to SageMaker endpoint, to Lambda function. You can like check out all of them in their documentation. There is 7 or 8 operators that you can use to deploy your bentos into a cloud environment. After that, like we need to install the exact one we want, and to do that, we can do bento.ctl operator install AWS, for example, SageMaker. Okay, so because like I have already this installed, I don't need to do it again. Once that is done, the next step would be to do bento.ctl init, which will try to initialize the configuration for like the deployed model that we want, just by providing like a bunch of parameters such as like the name. And we can actually see, because I have done already this, and it will take some time if we want to do it again. We can see it from the deployment config. Like you can provide the name, because like this is AWS SageMaker. We need to provide the region and what exact instance type we want to use, and maybe the number of like the instances. Once that is done, what we will need to do next is actually bento.ctl dot build, actually bento.ctl build. And this exact like code, what tries to do is take the exact bento that we want, that was already built using this deployment pipeline, and build a Docker image with all this configuration that we have provided here, like this requirement and this system packages, and then push that Docker image into the container registry, in this case, because it's SageMaker Elastic Container Registry. And like once that Docker image is built and pushed into the registry, we can finally just run bento.ctl apply tf deployment config, and this will start deploying the model into SageMaker. We can see actually all of this. Okay, so actually this has passed, and after that we run to the BentoML model deployer step, which deployed the model locally into the exact port that we give it. And now maybe let's try to see all of this in the other interface. Sorry for like this. I'm gonna need to switch back. Because like I have run this already before, as we can see, our ZenML YOLO v5 sign language endpoint is already in service, and we can use it at any time. And also what we can check is the local deployed model. And this is a very like cool thing of BentoML, that it's give you a Swagger interface, so you can see actually like everything related to the service you created. So we have actually two endpoints here, one for predict and one for predict image for this model, and we can see the matrix like of what exactly was run. So if we try, we can see actually like logs of everything that happened with our service. This is like our demo. I hope you enjoyed this, and like you can actually find everything related to this demo in our repositories. And like if you like this, please give us a star, and feel free to ask any question at ZenML Slack. Thank you so much, everyone.